Hey everyone. Hope you're having a good day. I know I'm not there, but normally you would have this as a pair deck, but today you're going to get this as an Ed puzzle. So you're going to be submitting your answers through Ed puzzle instead of the way you would submit them through pair deck, and I'll make sure that it pauses at the right times for you to give those answers for me. So today we're looking at Unit 6, Lesson 4. I know that you should have a handout for this that has much smaller sheets, but I'm going to do this one slide at a time. So this is Unit 6, Lesson 4. We're looking at distances and then how they're involved in circles. So circles, yay. No, we'll put a circle around it, I guess. So we're actually going to build equations for circles. That's the whole point of this exercise, is to be able to create an equation so that we can graph a circle. So our goal is to be able to graph a circle with an equation. But of course, we're actually doing this in a way where you're going to explore a little bit more of this yourself, or we're going to explore it together, I guess. And instead of me just giving you an example and then saying that this is it. So let's look at the warm-up slide. So here we have 2 points, P and Q. And Andre says, I know that I can find the distance between 2 points in the plane by drawing a right triangle and using the Pythagorean theorem. And this is something we've done before. And then he says, but I'm not sure how to find the lengths of the legs when I can't just count the squares on the graph. So we actually did this with when I can't count the squares on the graph. We've done this counting the squares on the graph. So how can we figure out, based on what they've given us, how to do this? So it says, explain to Andre how he can find the lengths of the legs in the triangle in the image, and then calculate the distances between points P and Q. Well, I will do the first part, and then I'm going to have you do the second part. So I will explain for you how we can find the distances between those, and then you, using those distances that you'll find, can calculate the distances between P and Q with the Pythagorean theorem. So if we can't count the squares on the graph, we can subtract the x and y values. And in this case, because we're using the Pythagorean theorem and we're going to be squaring things, you don't actually need to make sure that your order of subtraction is good. You just need to make sure you're subtracting x with x and y with y. So y minus y, that's going to be, we can do 22 minus 12. And then x minus x, we're going to have 53 minus 8. So if you did the subtraction here, you would get the distance on y is 10, and that the distance on x is 45. So using 10 and 45, I would like you to now do the Pythagorean theorem using those as the side lengths of your triangle and calculate the distance between P and Q. Okay, now hopefully that you've done that. Let's actually just walk through it real fast together. If we do 10 squared plus 45 squared, that should equal to our distance squared. I'm still going to call it c. So that would give you 100. And then 45 squared is a big number. That's 2025. So when you add those together, you get that c squared is 2125. And then we're going to do the square root of 2125. And you do not have to simplify that. I would leave it as a decimal answer. And so that's, I'm sure, what I gave you as your multiple choice there. Or maybe I just let you answer a number. But I would say that this one here is 46.1. So we're going to stick with rounding side lengths to the nearest tenth. So I would say this is 46.1. So finding distances using Pythagorean theorem. It's going to show up multiple times here and is involved in the creating of the equation of a circle. So let's keep going. Circling the problem. This image shows a circle with 6, 10 and a radius of 17. Now we know that a radius, if it's a radius of 17, one thing we know is that the radius is consistent throughout the circle. So that means we just talked about distance with the Pythagorean theorem. This means distance from center to edge is always 17. So essentially, what we want to do is test, can we use 6, 10 and then the point 1425 and find the diagonal distance between those and see if it's 17. So I'll start you with a little setup here. I'll have it pause, I'll have you finish, then check your work. So 14, 25, just to estimate kind of where that's at. 14 and 25, it's going to kind of be like around there if it's on the circle. So I'm going to write out the 2 points that we're using here. So we're using 6, 10, and we're using 14, 25. So just with the other 2 points that we used on that triangle, we can use the same thing here. I actually tell my algebra students that the best way is to kind of stack and subtract. Now, even if we get negative numbers, that's okay. But we're going to do 6 minus 14. And I believe that's going to get us negative 8. So 6 minus 14. Yep. So negative 8. And then 10 minus 25 is going to be negative 15. So we're going to use those numbers. I would like you to use 8 and 15 and then see if that gives you a length of 17 as a distance between the two. All right, so let's actually calculate this out. If we did the Pythagorean theorem, and if you use positive 8 or negative 8, you'll get the same answer because we're squaring it. It's going to make it positive. So 8 squared plus 15 squared. We want to know, is that equal to 17 squared? So 64. I believe this one is 225. I'm just never confident, so I'm going to check on my calculator. Yep, it's 225. And 17 squared is one I don't have memorized, so I'm going to multiply that on my calculator as well. And that gives us 289. So last test here is, does 225 plus 64 make 289? It absolutely does. So if we get 289 equals 289, then we can say, yes, it is on the circle. Because we have proven that the distance between those 2 points is 17. So if we put that 14 and 25, that would be like right here. And we'd have a distance here of 17. Then I believe the vertical, right, the y's gave us 15. And then the horizontal gave us 8. And 8, 15, 17, that's a Pythagorean triple. So we can always draw a triangle like that. That's going to bring us to our next one, which is another point to test on the same circle. So we have the same center here, the same distance. We have a new point to test, 22 comma 3. I'm going to ask you to do the subtraction and to do the Pythagorean theorem portion of this yourself to check and see, is 22 comma 3 on the circle? All right, so let's do some of the subtraction here. Get our numbers, and 6 comma 10, and do this work here. So 22 minus 16, or I'm sorry, minus 6, that's 16. I misspoke there, swapped my numbers. 3 minus 10 is going to give us negative 7. So we want to know, do 16 and negative 7 make a distance of 17? So we can say 16 squared plus 7 squared, is that equal to 17 squared? So 16 squared gives us 256. This is 49. And 17 squared, I believe, was 289 on the last one, right? Yeah, 289. And if you add up the left-hand side, 256 and that 49, that gives us 305. And that is not equal to 289. So since it's not equal, we can say no, it's not on the circle. That's because our distance doesn't work to make 17, because we still are working with the radius of 17 units. Okay, so let's keep going. We've done this twice now with two different points. How can we determine if we had any point on this circle? So I used a couple different points. We did some subtraction between them, and then we used those numbers to do the Pythagorean theorem. So we can use basically the difference between our x and the difference between our y, and square those as our horizontal and vertical legs of a right triangle. So we can say, let's just I'm going to kind of write these out to represent it. So difference in x, and then we'll do difference in y. And then we'll have our info from the circle. So the difference in x, we did this. I'm going to use just the number x, I'm sorry, the letter x, the variable x, as the placeholder here. So we were taking our x value and we were subtracting it from 6. Now, you also could do this as x minus 6, because I told you we squared it, right? So we like to put variables first, so we're going to use x minus 6. And so let's follow suit and do the same thing for y. Instead of saying 10 minus y, we'll write it first, so we have y minus 10. Because we're just doing some subtraction between them, because the sign didn't matter, and the information from the circle would be the radius. And in this case here, they gave me 17. So when we do the Pythagorean theorem, we're going to use these three pieces, but they're going to be squared and written alongside each other. So we would have x minus 6 and square it. Let's use a neutral color for in between here. I'll use green for in between here, that's fine. We want a squared plus b squared equals c squared. So we had our difference in y, so y minus 10 squared. And then we had that equal to the radius squared. So in this case, it was 17. but it could also be r. So this is the same thing as r if we didn't know what it was to be squared. So in this case, this is what we were using to test any point on a circle. And that actually turns out to be the equation of this circle. Because if you threw a point in there and you tested it and it worked, it would land on the circle. And a graph is literally just a visual representation of everything that makes an equation true. So how can we determine if x comma y is on the circle? Using this equation right here. So let's move on to some sort of examples, building equations for circles. So based on our previous one, we had a center of 6 and 10, and then we had a radius of 17. We want to write an equation that would allow us to test a particular point on this circle with a different center and a different radius. So we can do that using the same numbers and the same sort of strategy. We're going to take our difference in x, our difference in y, and have our radius be our ideal hypotenuse of the right triangle we would be creating between these points. So let's write that equation together and then see how it turns out. So for our difference in x, we would take x and we're going to subtract. Our x value here is -3. So I can do x minus -3 squared. And then the difference in y, we can do y minus, and then the y value here is +6, so we can use 6 squared. And this should be equal to, the radius was 13. So if r is 13, we want this to be equal to 13 squared. Now you can write out 13 squared, which is 169, but I think I kind of like it this way and just showing that it's the 13 squared. Now there is another way of writing this, and we're going to simplify it a little bit. And really, we're just going to change this here so that this says x plus 3. Because when you subtract a negative, it's the same as writing a positive or a plus. So we're going to have here this. And again, I do want to reiterate the reason why we can put the variables first and the order of the subtraction doesn't matter is because we are squaring it. It will always make this answer be positive. So distances we don't measure in negative amounts, and that's why we're allowed to write our x and y's first instead of trying to subtract those from the numbers that come from the center. So what equation would allow you to test this point on the circle? Either of these are good options. Okay, so now that we have an equation that we can use to test a point on a circle, we're going to use it. And I'm going to have you test whether 9 comma 1 is on the circle. So I'll write down the equation from the previous box or slide, and then you can do the testing. And then we'll come back and I'll show it to you all together. So the equation that we created, I'm not going to do the color coding part on it here. We said x plus 3. I like the simplified version, so I'm going to use the plus. Plus y minus 6. And sorry, it was x plus 3 squared plus y minus 6 squared is equal to 13 squared. So I would like you to use this. These are your values of x and y that you'll plug in and test to see whether this is true. All right, moment of truth. What did you get? Well, let's test it here. If we do 9 plus 3, and we do 1 minus 6, is that going to be squared on both of those. Is that going to be the same as 13 squared? Well, 9 plus 3 is 12. 12 squared makes 144. And 1 minus 6 is negative 5. But when we square it, we get a positive 25. And 13 squared is 169. So let's add those guys up together. I believe this is going to work out for us here. So 144 plus 25. Yep, it makes 169. And if you didn't recognize it already, it's a 5, 12, 13. So 169 equals 169. Yes, it is on the circle. All right, so that's how we can use our equations to test it. Now, we're going to just build kind of a generic version of this equation. So this image shows a circle with a center of -3, 6 and a radius of 13. Now, we want to suppose instead that we have a circle with center of HK and a radius of R. So we've done this with other values. Oh, my highlighter is too small there. We want center H comma K, and we're going to use a radius R. And so using that information, we want to write an equation that would allow us to test a specific point on the circle. Now, the way we were doing this is difference of x, difference of y, and then each of those being squared and then added together, and then equal to our radius squared. So I'm going to color code these parts so that you can see. We were using the difference from x and squaring it. Now we had x, and then we were subtracting whatever our other x value was. I'm going to try to use a third color here. I guess I'll use black for h comma k, because this is going to be x. We would subtract, and then if our x value is h, we would do x minus h and then square it. We're going to add that to the difference in the y values. So we would use y and then subtract, and whatever our y value is of our new point. And our new point here, that value is k. And then we would square it. And this was equal to, we used radius squared. But in this case, they're telling us the radius is r. So we would say this is r squared. Now, just to show you the parts that match here, h and k come from that center in that highlighted green part, and then the radius r is that pink part. Those were the three places that we were putting in pieces of information that they gave us. So we can make a general form like this, where we can input any center and any radius, and have a way to test if the point is on the line. And if it's a way to test if a point is on the line, on the circle, on the exterior of the circle. But if we can use it to test if any point is on the exterior of the circle, it also means that's the way to graph the circle. So that is going to be the general way we would build for our circles equation. Meaning, hey, look, I think that right there is exactly what we just built on the previous page. This was basically exactly what we had come up with by filling in pieces that we already knew. So we had x minus h squared, added it to y minus k squared, and said it was equal to r squared. So this is going to be very important. So please write this down in your notebooks, or make sure that this page from your handout gets glued into your notebook, because you do not want to lose it. This is the important part from this lesson. Um, so before we look at the graph part below, we want to really look at why are there two subtractions in this equation? And when they say this equation, they mean this one up here. So when they say this equation, they mean this. They're like, hey, why are we subtracting here? So I'm going to kind of write that answer as a little bit of a summary in between underneath here. So this actually comes from, we can say the subtraction is from finding the horizontal or x distance and the vertical distance, which is y, to use in the Pythagorean theorem. And basically, you can think about it this way. If we have that exact equation there, this is really a squared plus b squared is equal to c squared. We're just writing them with different amounts. We want our c to be the length of the radius. We want a and b to be the vertical and horizontal distance, but because the center of this circle can be anywhere, and the point we could be testing could also be anywhere, we have to actually do that subtraction to find those numbers. So that's where that subtraction is coming from. And the order of that subtraction technically doesn't matter, but is best when used this way because we do need to square it. So, yeah, that is the equation of a circle, and it's based on the distance formula, which is another word for saying the Pythagorean theorem, because we often use Pythagorean theorem to calculate distance between 2 points. And I'm going to have you do one or two last exercises here. So if I gave you this circle, your job is to now write the equation for this given circle. So I'll start you off with some things to think about writing down. So you would want to find the center of that circle, and you would need that as an ordered pair, and you would need to find the radius of that circle, and those are two pieces of information that you would need in order to write this. All right, so let's go over this one. The center of this circle is at -2, +1. And the radius of this circle, you can count horizontal distance here and just count from the center over to the side. This is 1, 2, 3, 4, 5. So it's going to have a radius of 5. Because remember, the radius is from the center to one side, not the entire distance. That's the diameter. So now using those would be like our values for h and k and r. So in our equation, we would say x minus -2 or +2. I'm going to use +2, but if you wrote minus -2, that's okay, squared, plus y minus 1 squared is equal to 5 squared. You could also write that out as 25. But that is the equation of the given circle. Okay. Now, if I don't give you a picture and I just give you the information, can you do the same thing? So let's write the equation out. It has a radius of 7, so r is 7, h is 4, k is -1, I can say x minus h, so x minus 4 squared plus y minus k, and in this case k is -1, so y minus a -1 is like y plus 1 squared, and is equal to 7 squared. Or you could write 49. And that would be the equation of this just from text. So hopefully, after this, you're feeling pretty confident about deriving an equation for a circle in the coordinate plane. Remember, it comes from the Pythagorean theorem. So you can just say comes from Pythag. And just remember that that's what we use it for. So it's based on a squared plus b squared equals c squared, but instead we're using x minus h as our a, y minus k as our b, and r as our c. And that's it. If you have more questions, you can always ask me on Monday when I am back, or you can shoot me an email over the weekend too, and I'll try to respond, but no guarantees on that one. Um, Good luck with your homework. I will make a video for this homework assignment, so you can always check that out if you have more questions.